Quantum mechanics. Einstein's objections to quantum mechanics. Newspaper headline on 4 May 1935. Einstein played a major role in developing quantum theory, beginning with his 1905 paper on the photoelectric effect. However, he became displeased with modern quantum mechanics as it had evolved after 1925, despite its acceptance by other physicists. He was skeptical that the randomness of quantum mechanics was fundamental rather than the result of determinism, stating that God is not playing at dice. Until the end of his life, he continued to maintain that quantum mechanics was incomplete. Bohr versus Einstein. Two men sitting, looking relaxed. A dark-haired Bohr is talking while Einstein looks skeptical. Einstein and Niels Bohr, 1925. The Bohr-Einstein debates were a series of public disputes about quantum mechanics between Einstein and Niels Bohr, who were two of its founders. Their debates are remembered because of their importance to the philosophy of science. Their debates would influence later interpretations of quantum mechanics. Einstein-Podolsky-Rosen paradox. In 1935, Einstein returned to quantum mechanics, in particular to the question of its completeness, in a collaboration with Boris Podolsky and Nathan Rosen that laid out what would become known as the EPR paradox. In a thought experiment, they considered two particles, which had interacted such that their properties were strongly correlated. No matter how far the two particles were separated, a precise position measurement on one particle would result in equally precise knowledge of the position of the other particle. Likewise, a precise momentum measurement of one particle would result in equally precise knowledge of the momentum of the other particle, without needing to disturb the other particle in any way. Given Einstein's concept of local realism, there were two possibilities. 1. Either the other particle had these properties already determined, or 2. The process of measuring the first particle instantaneously affected the reality of the position and momentum of the second particle. Einstein rejected this second possibility, popularly called spooky action at a distance. Einstein's belief in local realism led him to assert that, while the correctness of quantum mechanics was not in question, it must be incomplete. But as a physical principle, local realism was shown to be incorrect when the aspect experiment of 1982 confirmed Bell's theorem, which J.S. Bell had delineated in 1964. The results of these and subsequent experiments demonstrate that quantum physics cannot be represented by any version of the picture of physics in which particles are regarded as unconnected independent classical-like entities, each one being unable to communicate with the other after they have separated. Although Einstein was wrong about local realism, his clear prediction of the unusual properties of its opposite, entangled quantum states, has resulted in the EPR paper becoming among the most influential papers published in Physical Review. It is considered a centerpiece of the development of quantum information theory.